Hello everyone, this is Amit Latigra. In this video, I'm going to demonstrate how can we check whether an entered number is Armstrong number or not. So to begin with, what number we are considering as an Armstrong number? So usually for any number, we need to extract its digits. After extracting digits, we need to find a cube of individual digits. We need to add them together, and whatever the number we are getting and dash number, if that number and the original number both are same, meaning it's Armstrong number. Let me explain you with an example. Consider a number, say 24. So as per this, we need to extract the digits. So here digits are 2 and 4. After extracting the digits, we need to find a cube of both the digits. So 2 cube and 4 cube. We need to add them together. So 2 cube and 4 cube. We need to add it together, whatever the number we are getting. If this number and original number both are same, then it is Armstrong number. So here 24 is not an Armstrong number. Let's consider one more example, say 153. We need to extract the digits. We need to find its cube. We need to add them together. 1 plus 5 cube, that is 125, plus 3 cube, that is 27. If I add these three numbers together, 125 plus 126 plus 27, so it is 153. So this number 153 and the original number both are same, meaning 153 is an Armstrong number. So this is a logic. We need to extract digits from entered number. After extracting a digit, we need to find its cube. After finding its cube, we need to add it together, and finally whatever the result we are getting, we need to compare it with original number. Then it is considered Armstrong if both are same. So how can we extract the digit? Let's consider 153. Already I discussed this in my previous video when I discussed how can we find sum of digits. If we perform a modulo operation, if we divide this number with 10 and if we check the remainder, then it is nothing but the rightmost digit of a number. Then if we divide this number with 10 and if we find its integer value, so here it is 15.3, but let's consider any, let's do not consider any digits comes after decimal point, only the integer number without decimal point, then it is 15. We need to repeat the process. This 15 further, if we find a remainder after dividing it with 10, we are getting second most digit from right side. If we divide it with 10, 1.5, let's consider only integer parts, 1. Similar way, 1 modulo 10, we are getting 1 as the remainder. 1 divided by 10.1, so 0. Once we get 0, we need to stop the process. So it's a repetitive process basically. If we find its cube, then here we need to find 3 cube. So that is 27. Let's consider one variable sum. Let's initialize it with 0 because we need to add this value to sum each time. So that's the reason why we need to initialize it with 0. Because if we are adding 0 to any number, it remains unchanged. Similarly, if you want to find a multiplication repetitively, then we need to initialize it with 1, because if we multiply 1 with any of the number, the result remains unchanged. So 5 cube, 125, we need to add it to the sum. Similar way, 1 cube, whatever the result, we need to add it to the sum. Finally, sum we need to compare with original number. If both are same, it is Armstrong number. So let's consider its flow chart, how it looks like. Let me draw a flow chart. We need to start our flow chart. So start. Then we need to take an input from the user. So input number. We'll modify this number in subsequent stages. So it's better to take its backup because at last we need to compare it with original number. So let me consider one more variable, that is original number, and let's initialize it with number itself, and also let's initialize sum with 0. So my original number is nothing but the number and sum is equal to 0. Then my condition, purpose of condition, we are going to take a loop. So to avoid what we can say infinite iteration, we need to control the loop. So my condition is number not equivalent to 0. Two possibilities. What if it is true? What if it is false? Let's consider true this side and let's consider false this side. So here it is false. So what if it is true? This condition is true. Number is not a 0. Means we need to find the digit. So let's find a digit. How can we find a digit? Digit is equal to number modulo 10. Then we need to add it to the sum after finding its cube. So another operation is we need to find its cube. We need to add it into the sum. So sum is equal to sum. That's the reason initially value of sum is 0 to make a generalized statement, plus number, whatever the number we are having, we need to extract its digit, which we already extracted. So here it is digit, and we need to find its cube. So digit and its cube. So this we need to add it into the sum, and we need to replace the number with integer representation of number divided by 10. And we need to go to the beginning of the loop. So this part repeats till the number becomes 0. Once number is 0, what we need to do, we need to check the value of sum with the original number, because here number we are replacing with subsequent values. So here my condition, if this loop is completed, iterations over, then is my original number same as value of sum? What if it is true? What if it is false? So if it is true, sum is actually the original number, then it is Armstrong number. So we need an output that print number is Armstrong. Else, if it is false, we need to print number is not an Armstrong number. So two possibilities, either it is a true or false. If true, Armstrong. If it is false, not an Armstrong. And in both cases, we will complete the program. So it's stop. So this is a simple flow chart, starting with taking a number from the user. After that, taking its backup, initializing sum, then loop, extracting digit, find its cube, adding to sum, replacing number after dividing it with 10. Once this loop is over, once we come to the false, we are checking the original number. If both are same, it is Armstrong, else not. Let's take example of the same number, which is an Armstrong, that is 153. So consider number is 153. So we are storing it into the original number. So original number is 153. Sum is 0. Here 153 is not equivalent to 0. This is true, meaning we need to extract its digit. So 153 modulo 10. So digit is 3 now. We are adding its cube. So 3 into 3 into 3, 27. That we are adding it to the sum. 0 plus 27. So it becomes 27. Number is equal to integer representation of number modulo 10. So here number we are replacing it with 15 now. So now here we are checking 15. It is not 0. Condition is true. We are extracting the digit from the rightmost side. So now it is 5. 5 into 5 into 5, 125. Value of sum is 27. 27 plus 125, so 152. This is the value of sum. Number we are replacing it with 15 divided by 10, 1.5. It's integer representation, that is 1. So now 1 is not equivalent to 0. True. Extracting digit 1 modulo 10. Remainder is 1. 1 cube 1. We are adding it to the sum. So sum is now 153. Number is equal to 0.1, integer representation 0. 0 is not equivalent to 0. Condition is false because it is equivalent to 0. So original number and sum we are comparing. Original number is 153. Sum is also 153. It is true. So it is going to print 153 is the Armstrong number. And finally stop. So this is a simple flowchart. And based on this flowchart, let's write its Python program where we need an input from the user. So number, let's take an input, enter any number. So this is what my prompt. This number, let me store it into original number. So original number is equal to number. We need to initialize sum with 0. As per flowchart, my while number is not equivalent to 0. This is my while loop. So we are here, then we need to extract the digit. So how can we extract the digit? Digit is equal to number modulo 10. So here we are getting a digit. Let's add it into the sum. So sum is equal to sum plus to find its cube. Digit 2 asterisk sign indicates raised to, digit raised to 3. So to find a cube, to find a square, we can write 2. So here we need to find its cube. We are adding it into the sum. We are replacing number with integer representation of value which we are getting after dividing number with 10. So that we are considering here. So this is my loop part. Once loop is over, once this condition is false, it comes here. I need to check value of sum with original number. If sum is same as original number, what if this is true? If this is true, I need to display a message that my number is an Armstrong number. So number is my original number. Let's write say original number because number is 0 at end. So original number is Armstrong number. And else, if it is not true, then we need to print number is not Armstrong number. So this is a simple program. Let's check its output. So let me enter a number, say 153. 153 is Armstrong number. Let me consider say 25. So here 2 into 2 into 2, 8, 5 into 5 into 5. 125. 133 is answer. So 25 is not Armstrong number. So this is a simple Python program. This is a flowchart. Let's end this video here. I hope you enjoyed this video. Thanks for watching this video.